In the last video, we learned where big elements keep bubbling to the end of the array by adjacent elements. Today, let's look at another simple selection sort. Let's see what that means with a clear example.
We'll use this array as our running example: 29, 10, 14, 37, 13. We want to sort it in ascending order using selection sort. In Pass 1, we focus on the entire array because nothing is sorted yet. We start by assuming the first element is the smallest. So we set min_index equals 0, pointing to 29. We then scan the rest of the array to find the true smallest element. Compare 10 with 29, 10 is smaller, so min_index becomes 1. 14, 37, and 13 are all bigger than 10, so min_index stays at 1. So the smallest value in the entire array is 10 at index 1. Now we swap the element at index 0 with the element at min_index, index 1. So 29 and 10 are swapped. After the swap, 10 is at the front, in its final sorted position. We scan the rest of the unsorted part. 14 less than 29, min moves to index 2. 37 greater than 14, no change. 13 less than 14, min moves to index 4. In Pass 3, indices 0 and 1 are sorted. We now focus on 14, 37, 29. Step 1. Assume index 2 is min. Min_index equals 2, value 14. So the smallest element in the unsorted part is 13 at index 4. Here, 14 is already the smallest in the remaining portion, so min_index stays 2. No swap is needed. Unsorted part is 37, 29 at indices 3 and 4. Current array: 10, 13, 14, 37, 29. We find that 29 is smaller than 37, so the minimum is at index 4.
First, we initialize the minimum index. Then, we swap the elements to sort the array. To sort this list, we need to find the smallest element. This minix variable tracks the smallest element we've found so far. It's the key to the whole sort.
Selection sort loops. Selection sort has two loops. Outer loop chooses where the next sorted number should go. Inner loop searches the remaining unsorted part to find the smallest number. Outer loop in selection sort. The outer loop goes from left to right. Its job is: pick the current position. Assume that position should get the smallest remaining element. After the inner loop finds the real minimum, swap it into this position. So each round, the sorted part grows by one element. Example: first round, place the smallest at index 0. Second round, place the next smallest at index 1. Third round, place the next smallest at index 2. And so on. Inner loop in selection sort. The inner loop scans the unsorted part. Its job is: start from the next element after the current position. Compare each value with the current minimum. Update the minimum index whenever a smaller value is found. So the inner loop is like the snake's eyes moving across the rest of the array, searching for the smallest prey.
Imagine the array as a line of numbers. At each step, the snake stands on the current position, finds the smallest one, and swallows it into the current position. That number becomes sorted. The snake starts at the beginning. It looks at two numbers at a time. If the left is bigger, the snake swallows and swaps them. To the right, one swap at a time. Let's compare bubble sort complexities. Worst case is reverse sorted, O of n squared. Average case is random, still O of n squared. But best case is already sorted, taking linear time. Know your algorithms. Let's analyze selection sort's time complexity. Worst and average case is squared because of nested loops. Even in the best case, it's still O of n squared. It always scans everything, making it quite inefficient. Which sort should you actually use? Selection sort is great for minimizing costly swaps, while bubble sort is mostly just for teaching concepts. Use selection for performance, bubble for practice.